Okay, so here we are on quiz number 4. Quiz number 4 from Unit 2, covering homeworks 4 through 7. All right, so wants us to take each of these decimals and write it as a fraction. So let's take 14.26. How do we make that into a fraction? Well, it's 14 and 26 over 100, isn't it? Because, right, this 26 is ends in the hundreds place. Now, how do you convert that to a normal fraction? You multiply the bottom and add the top. So that'll be 1400 plus 26. You keep the denominator the same. So that's going to be 1426 over 100. And then that is reducible. Divide top and bottom by 2. That'll be 713 over 50. And there we go. It's completely reduced. There is the fraction. Okay, now for part B. That's part A. So bring down here part B. 0.008. Well, what place? That's the tenths place, hundredths place, and that 8 is in the thousandths place, isn't it? So that's 8 over 1,000. Reduce that, divide top and bottom by 4. That'll be 2 over 250. Divide by 2 again. It's 1 over 125. So we reduced that fraction. Let's try part C. I'll go to a fresh screen here. Part C. Negative 9.87. That's negative 9 and 87 hundredths. Right? So now we multiply and add. So that's negative. That's going to be 987 over 100. And that's not reducible. So there we go. How do I know it's not reducible? Well, the only thing that goes into 100 is 2 and 5. Right? 100's 10 times 10, which is made out of 2's and 5's. So those are the only prime building blocks in a 100. And I know 2 and 5 do not divide into 987. So can't be reduced. All right. D. 0.273. So that's going to be 273 over what? That ends in the tenths, hundreds, thousands place. So 273 over 1,000. And that's it. We cannot reduce that because, again, 2 and 5 don't go into the 273. So it's reduced as it's going to get. Okay, so here comes number 2. So write the results in scientific notation. So we're multiplying. 7 times 3 is 21. And then 10 to the 12th times 10 to the 17th, you add the powers. 12 plus 17 in the power there, that's 21 times 10 to the 29th, adding those powers. Now, are we done there? Is that the answer? Well, no, actually it's not. Why not? This is not scientific notation. It's the correct multiplication, but we have to change the form to be in scientific notation. What do we mean? Why? Because that's what they said, right? They said, write your answer in scientific notation. Why is that not scientific notation? Scientific notation must be the decimal after the first digit times 10 to some power. The decimal has to be after the first digit times 10 to some power. No, where's on the 21, where's his decimal? It's right there. Right? When there's no decimal showing, you know where it is. It's at the end of the number. So it's got to be right there instead. So can I just put it right there and keep everything else the same? Can I just say, okay, just move it back one where it's supposed to be, right? Because it was the number 21. Now it's 2.1 and just keep everything else the same? No, I've changed the number. So if I'm going to change this part of the number, I must change this part of the number in the opposite way so that overall I'm not changing anything. Right? Does that make sense? We're trying to make this number right here look different without being different. I got to change the way it looks without changing its actual value. Well, how do I do that? Well, when I moved the decimal back one place here, back one place, I made that number smaller, right? It went from 21 to 2.1. That's smaller. So if you make that part smaller, you got to make this part bigger so that overall you haven't changed the number. There's the answer, 2.1 times 10 to the 30th. 2.1 times 10 to the 30th. Does that make sense? If you make one part of the number smaller, you got to make the other part of the number bigger so that overall you haven't changed the number at all. You've only changed the way it looks so that it looks like it's supposed to look, scientific notation look, and that means decimal after the first digit times 10 to some power. That's the look we had to give it. That's called scientific notation. Okay, let's go to a fresh screen, try B and C. On B, same thing. We have, I'll bring them over here. In fact, let's bring them up here. There we go, part B. 8 times 10 to the 11th divided by, I'm going to write it as a big fraction, 2 times 10 to the 5th. Okay, we know what goes on here. You divide these numbers. 8 divided by 2 is 4, and you subtract powers, don't you? Times 10 to the 6th. 4, they want you to write that way, 4 times 10 to the 6th, right? We subtract powers, divide the numbers in the front, subtract the powers. Okay, how about this next one? Same kind of thing down here. I'll do part C here. 5 times 10 to the 9th times 6 times 10 to the 6th divided by 15 times 10 to the 12th. Okay, well, 5 times 6 is 30. 10 to the 9th, 10 to the 6th. Remember, these powers add. Just keep the denominator the same so far. 30 divided by 15 is 2. Subtract these powers. 2 times 10 to the 3rd. See what happened there? Tens that are on the same level, see these two tens that are both on the top, the powers add, but tens that are on different levels, the powers subtract, don't they? Just like the 5 and the 6 on the same level multiply, the 30 and the 15 on different levels divide. There we go. Okay, let's come down for number 3. So on a map, a half an inch is 6 miles. So if two cities are 17 inches apart, what is the actual distance between them? So we're doing inches on a map to actual miles in real life. So a half an inch goes with 6 miles, right? Half an inch goes with 6 miles. Is in the same ratio as 17 inches. 17 inches is to x miles. Well, you don't need to write inches and miles. We know inches are on the top, miles are on the bottom. So there's our little equation. How do we solve that? Well, we diagonal, cross multiply. A half times x is 6 times 17. A half times x is, what is that, 60 and 42, 102. And now what's the final step to solving for x? X is saying, I want to be alone. Get rid of this half. Well, you got to multiply both sides by 2 because that's 2 over 1 and it'll cancel that out. And this side will be 204. So x is 204. It's 204 miles. Okay, so number 4. Vaughn has scored 38 goals in her soccer kicking practice. Her success to failure rate here is 11 to 10. So let's write that first off. Success to failure rate is 11 to 10, right? Okay. And then where's the 33 go? She scored 33. So what's that? That's success, huh? Scored is 33. That's success. Failure we'll call x. All right, you know what to do. Cross multiply. 11 times x is 10 times 33. 11x is 330. Divide by 11 to solve for x there. X is, what's that, 30 if you divide in your calculator. And that's my answer. Whoop, nope, careful. That's the mistake a lot of people make. Now 30 is not quite the answer. We're almost there, but it's not 30. Why? Because x, what we just solved for, 30, which is x, is failures. So that means 30 failures. 30 failures. What did they ask me for? The number of goals attempted. So if she's 33 success and 30 failures, that means you add them up, don't you? 63 were attempted. So you got to be a little careful there. 63 were attempted, right? She succeeded 33 times, 30 failures, add that up, 63 attempted. All right, so here on number 5, they want me to order these from greatest to least. So let's do it. So I'm going to grab the first one over here. 22.4219. So the trick is to line them up vertically. Next is 22.42193. The next one, 22.422, and then 22.42188. Okay. So where are we at on these? Well, notice they're all the same to here. 22.42. They're all the same to there. So it's really just comparing what comes after that. 190 really, just fill in zeros there. Fill in zeros here. 200, 193, 188. So who's the biggest one? Which one is, because they want us to go from greatest to least, so which one's biggest? 200. So this one's number 1, 200. What comes next? Number 2 there, 193, followed by 190, that's number 3, and number 4, the lowest one, 188. So there we go. Where do we see that? 22. I'm not sure. I don't see that one. From greatest to least. Okay, so let's try. Okay, so that's good. Now let's try B. Go to fresh screen here. Okay, on B, same kind of thing. We're going to order from greatest to least. So here, I'll come down here. I don't have a lot of room. So minus 4.694, minus 4.684, minus 66084, and minus 4.68. So we got those. Now, let's compare those. They all start off with minus 4.6. So that part's the same. And then it's 940, 840, 800. All right, so now we want to start with want to go from greatest to least. Because these are negative, the greater one will actually be like the least negative. Do you know what I mean? Which one's the least negative? This one's number 1. He's negative with an 84, followed by number 2, which is 800, number 3, which is 840, and number 4, which is 940. So greatest to least is actually least negative, right? If you know what I mean, right? This number's greater. -1 is greater than -2 because it's less negative. So there we go. There's the order. This one is the least negative, -84, followed by 800, 840, and 940. That's the most negative. So he's actually the lowest number. There we go. Number 6 was to take this number, and they want me to do what with it? Write it in scientific notation. So it's going to be 2.3 times 10 to some power. How do you know what power? Well, if the decimal was placed right there between the 2 and the 3, how many places to the right would it need to move to get to the end? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 places. 2.3 times 10 to the 10th. Okay, so now on this one, could start with this part, minus 4.6. Now the repeating part, 9,6, we're going to write out a few of those. 9,6, 9,6, 9,6. We might come back and do more. Let's see. This one is negative 4.696, 696, etc. The next one, negative 4.69. So the 69 is the repeating part. 69, 69, 69. And the next one, negative 4.696. And it just stops, no repeating part at all. Oh, wait. Did I skip one? I did. I skipped one. What am I doing? I skipped this one, which is negative 4.69, and then just the 6 repeats. Right. And then the last one is this one, which is negative 4.696, and it just stops, which means zeros the rest of the way. All right, now to compare. So I wrote them all out with their repeating parts. Now let's see where they're the same. They're all the same up to there, aren't they? 4.696. Okay, let me make them all positive at first, because that's easier. I don't want to worry about the negative thing. Let me do the positive first. So they want me to find the greatest. So which one is the greatest? So we're comparing. Let's fill in zeros so they all have the same. So just comparing these parts, which one of those numbers is the greatest? 9696. Oh, wait, hold on. I'm messing up. These should not be zeros. That was wrong, because these are repeating. They didn't end there. They're repeating, so it shouldn't be zeros. So which one is the greatest? Well, it looks like 9696 and 969. This would be another 6. Remember, this is the third one. Just keeps repeating 69, 69, 69. So these guys are both the same, aren't they? They are the same. And, oh, not the greatest, sorry. 696 is bigger than no. I'm getting totally confused, aren't I? Yeah, I'm just thinking I'm not being careful enough on this one. Let me try this again. Sorry, I am not being careful. I'm just being sloppy. Got to be really careful. If you just miss one little line up, it's going to be messed up. Let me try it again. So 4.6, and then what repeats is the 96. So 96, 96. This one, and I know they're negative. I'll do that later. 696. So 696, 696. Okay, next one. 4 point, and this one's 696969. Next one, 4.69, and then the 6 is repeated. this one 4.696, and it just stops. Okay, so there we go. They're all the same to there. So after that spot, which one's the biggest? These two are tied, 9, 6 and 9, 6, because this would be another 9 here. How do we know? Because this pattern is 9, 6, 9, 6, and be 9, so they're the same. So this is number 1 and number 2, really they're the same. So what would be number 3? Number 3 is right here, 6, 9, 6. Number 4, 6, 6, 6. And number 5, because this is just zeros out there, really. Because that one does stop right there, no repeating part, right? He just stops there, no bar, no repeating part. Okay, so that's the greatest. But now, remember, they're all negative. So that reverses everything, because the greatest negative is actually the lowest number. So this should actually be number 5, number 4, right? The greatest negative is the least, followed by that one. Number 3 is still number 3. Number 4 becomes number 2, and number 5 becomes number 1. So there we go, the greatest one. There we go on that one. So the greatest one is this one that ends, which means this one, or that one. B's out, E's out. It's either A, C, or D, right? Okay, now is number 1. Number 2 is this one, which is this one, 6 bar over 696. Bar over. Okay, yep, there it is. There's our answer. That has the right. You can tell the equal sign right there for these two, which came in last place, right? These two, which are actually equal. There's the right answer. Okay, so we're talking about 1/7. So if you take 1 divided by 7 in your calculator, you'll get 0.142857, and then it'll repeat. 142857, 142857, 142857. It just keeps repeating forever those 6 digits. So we want to find the 225th digit. So we've got to find out how many groups of 6 digits, 6 digits, 6 digits, 6 digits, 6 digits there are in your way on out to 225 digits. So 6 goes into 225. Just divide on your calculator. 225 divided by 6. Calculator will tell you 37.5. So that means this goes in 37 times. And then multiply 37 times 6. The calculator will tell you 222. Subtract. That's the remainder. So what does that mean about our answer here? That means there's 37 groups. 37 groups of 6 digits. 37 groups of 6 digits. So you do all 6 digits, all 6 digits, all 6 digits, all 6 digits, all 6 digits. 37 groups of this. And then in the last group, there's a remainder of 3. So in the very last group, we start the 142-142-857 thing, and we only go into it how far? 3 in. 142. 2 must be the last digit because we go the third spot in. The third spot in to the last group with the 142-857. So it's a 2. There we go. And then number 9. So let's come down here. 0.59. Well, that's just going to be 59 over 99. Remember how we learned that when you have a repeating decimal, so the repeating rule is if you have like point x bar, that means x over 9. If you have 2 of them, that means x over 99, etc. So this means 59 over 99. That was easy. Now what about the second one? Can we just go, oh, okay, well then that's just 8198 over 999. No, careful. When you have a number in the front, you got to keep that separate. So it's going to be 8, and then you have 3 x's is going to be over 999. So that's going to be 198 over 999. Like that. All right. So now, how do we simplify that? You multiply the bottom and add the top. Use your calculator. I'm going to use my calculator right now. I'm getting 8190. The denominator remains the same. Now, is that reducible? Yeah, you can divide top and bottom by 9. You'll get 910 over 111. And that's our answer. 910 over 111. There.